In this third video on trees, I'm going to show you a little procedure I wrote to print out a tree in kind of a nice way so it looks more like a tree. So this is the output of this program where I have built a tree down here using the insert method that we talked about in the last video. So insert 21, 11, and 35. So now we have a tree that looks like this. And then I insert all these other nodes, and you can see that the tree branches out like this. So the reason why I want to go over this is because the method I use to do this gives a way to traverse a tree without using recursion. But it's a little bit complicated. So here's the idea. Each one of these rows represents what's called a level. So the first level has just one node, the root. In this case contains 21. The second level contains two nodes, 11 and 35. Third level, 4 nodes. Fourth level, 4 nodes, and then finally the fifth level, 2 nodes. For each one of these levels, I'm going to build a list that has the nodes on them. And I'm going to actually build 2 lists. I'm going to build a list that has the actual nodes as a class. I'm going to build a second list that has just the info or the data. So I'm going to have a list that just has the 11 and the 35, for example, in the second level. Alright, so I put this in my string method. I've replaced my old string method with this new one. Excuse me. So I am going to count, first of all, how many levels I'm working with. I'm starting to count at 1 because, I'm a computer guy. Alright, here are the 2 lists that I'm going to maintain. One is for nodes and one is for strings, and they're essentially the same thing. It's just a matter of what information they store. So I'm going to have a list of lists. And nodes is going to store the nodes for each level. And then string is going to store the data from each level. So nodes, the first list in nodes will have just one, will be a list of nodes that just has one thing in it. The second thing from nodes, so if I wanted to type it this way, I would say nodes, so 1. Because this is a 2-dimensional list, nodes 1 is a list, and it's going to have this row in it, or sorry, this level in it. Okay? So I'm going to build these lists up. It's going to have these levels. Okay. Now, I need to keep track of a flag here. I need to know when to end. And I'm going to end when I get down below the 0 and 3, and I add all these nodes down here, and they're all none. So I know to stop when I get a list on a level where all the branches are none. Okay, so I'm going to maintain a flag called more branches, and more branches is going to be true if I'm adding to my list and I find if I find a branch that is not none, then I'll set that to true. Otherwise, I'm just going to keep it at false. Alright, so if the root is not none, well, I'm sorry, I've already added the root into the list of nodes and the string nodes. So this is my very first array. So nodes 0 is just this node right here, and string 0 is a list, and in that list it just has the number 21. Actually, a string 21. So string 0 is equal to that. Okay. Oops. Now, I want to keep building from there. So I check to see if the left and right are not none, and if one of them, either one, left or right, is not none, then there's more branches. I set that to true, otherwise I set to false. Now, you can't do a while loop in this, or for loop, I'm sorry, because you don't know the depth of the tree. We could figure out the depth of the tree, so we could go through and do a computation and find the depth and then make a while loop, but that just seems inefficient. So I'm going to do a while loop, and I'm going to do a while loop until I run out of branches. So while more branches. Okay, so here we go. We're going to loop through this tree, And the first assumption is that there are going to be no more branches, and then if we find a branch, we're going to set this back to true. We're going to append an empty list to the current list of nodes. So I've already got a list with 21. Now I'm going to append 2 empty lists, and I'm going to end up putting this information in. Alright, so for node in nodes I remember I is 0, so I'm looking at nodes in nodes I. So remember that I is 0, so we're looking at node 0 in this case, and node 0 only has the very first node in it. So it's node 21. Alright, if the node is not 1, so we're doing a for loop through this list of nodes. So for node in nodes I, if the node is not none, so 21 is not none, we're going to append the left and the right to nodes I plus 1. So now nodes I plus 1 is 1, and that's equal to a list. Oh, sorry, this should be a list. Nodes 1 is a list. Remember, we appended that right there. And in that list, we're appending node left and node right for node 0. Okay, so we're going to append node 11 and node 35. I should put this as a comment. And then if one of these, we also do the same thing with a string list. So the only difference between node, oops, sorry, there should be nodes. The only difference between string and nodes is that with nodes we're actually appending the node so we can look at the left and the right, whereas with string we're just appending the string version of the node so that we can use that to eventually print out. So we need the node so that we can construct the next level, so we can go left and right. This almost looks recursive, right? To make this list we need the previous list. We're using nodes I to create nodes I plus 1. But for the string, we're not going to have that information because we're only taking the string of the node. Okay, now we just check if this thing is not none, if one of these, the left or the right, is not none, then we still have more branches, and we set that to true. Okay, if the node is none, then we just go ahead and append none. Alright, so we keep doing that. So we've made 2 levels now. In the next go around, and if more branches, we add 1. So now I is going to be 1, and we're going to come back up to the while loop. We're going to append something to nodes. So now we'll have a nodes 2. And in that, we're going to do a for loop through nodes 1. So we're going to do a for loop, and we're going to look at these 2 nodes. We'll check node 11 to see if it's none. It's not. And then we're going to append its left and right. So we're going to append node 6, node 17. We'll also put those in the string. Then we'll go to the next node in this list, which is node 35. We'll append its left and right. And then this for loop will be done. We will have set more branches, so we're going to add 1 to I down here. Make this a little bit smaller. And we'll come back up, and we're going to append in the while loop. So we're going to append another array to nodes. So there'll be nodes 3. and that will add 1, 8, 14, 18. And then, so we've added the left and the right for node 6 and node 17. When we get to node 27, there's nothing there. So we're going to append nuns for left and right of those, and we'll append nuns for the left and right for node 45. But more branches has been set true from node 1 and node 8. Okay, we'll do this one more time. Nodes 4. We'll get a node 0. A node 3. And then a bunch of nuns. I'm not going to type all those in. More branches is set to true when we encounter the node 0 and node 3. We increment I, we come in, and then we start trying to append from node 0 and node 3, and we get a bunch of nuns. So we actually create a new list, nodes 5. And nodes 5, all it has in it are nuns. More branches never get set to true because all the nodes are none. So now more branches is going to remain false in this iteration through, so we're going to exit this while loop. And when we do that, I delete the last thing off from the list of nodes and the string of nodes. Oh, my doggy's here. She wants to scratch. Hi, doggy. Get away. So, even though we added this list of nuns onto our nodes, we're actually going to delete this off. Right here. So we delete those from the nodes and the strings, all those nuns. Okay, so now what we want to do is we've got this massive list of lists up here. Could be massive, depends on the size of the tree. And we want to print that out in a nice way. We can't just print the list, because then you'll have 21 over top of the 11, over top of the 6, over top of the 1, over top of the 0. You really want the 21 to be centered over top of the bottom row. So what follows next is really just a bunch of formatting and printing. I do a for loop here and go all the way through the strings. So the strings is the same thing again as nodes. It just has, instead of node 21, the string 21. So I go through do a double for loop, because that's a double array, or double list. And I do two things. First of all, for some of these, we appended the string none. So if it is a none, I convert that to a blank. And then what I'm going to do is compute the maximum length of one of the nodes. So if somebody types in 1,000,000, that's going to change the spacing on the nodes and how wide I need to make the tree. So what I'm doing here is just computing the maximum length of any of the strings in the nodes. So I get the max entry size, and from there I'm going to print this out. So I create a string to return, because this is a string method, and from there it's just formatting. I computed the left margin, so I did some math stuff to make sure that everything in each each level gets moved over the right amount. I created or did some math and figured out the spacing between the nodes on each level, and as you go down, that spacing gets smaller, and as you go down, the left margin gets smaller. And I made sure that everything was nice and centered. So I just did some math here, computing the left margin and the spacing, and then I created that number of spaces in the string. In here, I'm taking a number and making sure it's centered. So if somebody had put in 100,000 as an entry, that would have 6 blanks. So when I go to print a number like 18, I've got 6 blanks to work with. That's going to be centered in a sort of text box of length 6. 6. So this part right here, all this math here, is making sure that this thing is centered in the size of its box, and the size of its box is this max entry size. This for loop right here ends one of the rows, so we put it down to a new line, and then we return the string. And this is the output you get when you print out that tree. Not bad. I mean, it doesn't have the arrows connecting things. That would be impossible to do when you're just working with string output like this. To do that, you'd have to go into a GUI, and it just gets messy. Not worth it. I think you can see the tree just fine from this. The idea that I wanted to get at here, though, really comes back to this. This idea that you can use a while loop to sort of traverse this tree, and so you don't have to use recursion. But this isn't, I guess, obvious. I mean, if you look at the recursive traverse we have, whoops, down here, that's pretty short and really not that hard to understand. This while loop traverse, I mean, it's obviously much more complicated. So I think, you know, the idea here is that when you're using trees, recursion is necessarily less efficient, because every time you do a recursive call, you put that call on the operating system stack. So it is less efficient, it's more costly in terms of time, but when you're doing tree traversals, it's really just much easier to code, and probably worth the extra time. But it depends on how you want to do the tree traversal. In this case, we're doing a, let's see, breadth first. So we're going here, then to the next level, then to the next level. So if you want to do a traversal by depth or by level, and then this is, I guess, the way to do it. All right. So there is a tree traversal that doesn't involve recursion. It occurred to me after I finished this video that it might have actually been enlightening if I printed this string double list that I made. Remember that nodes and string really contain the same thing, just one's a string and one's a node. So I did that. It's a double list where each list inside the main list is one of the rows. So the first list is just 21. The second list is the second row, 11, 35. Then we have the third row, 6, 17, 27, 45, and so on. And then the last thing that we deleted had a bunch of nones in it.